Greetings, Algebra 2 Trig students. Mr. Rohde here. Sorry I'm not with you, but your substitute teacher is an Algebra 2 Trig teacher that can help you as well. Please use this video to get started. Pause and try some problems on your own, then come back to check them against the video as you feel confident. And then if you do feel confident, feel free to move on to the homework during the second half of class and give that a try this weekend. I will be back Monday to help continue to move things forward, but today is day 9. We're going to be breaking up activity 17 over 3 days. On this day 1, we are going to look at our factoring from back in semester 1, but also a new strategy called factoring by grouping. And then on day 2, similar idea, but a new strategy. So all in the same kind of themes here. So in your book, this is lesson 17.1 and 17.2. We're not going to do all of the lessons, but we're starting on page 267 here. So again, we're going to start with refreshing ourselves about some other factorings. We're going to do what's called the greatest common factor, or GCF. So as I look at something like this has got a GCF of 2 and x that can be divided out of all 3 terms. And so I wind up with 2x squared plus x minus 3. And then sometimes whatever's left here is hopefully something that I can factor. So again, I'm going to break that up into 2 parentheses. This is kind of our factoring from semester 1. What I know, the 2x squared is going to be 2x times x. And then guess and check, the 3 is either 1 times 3, negative 1 and positive 3, or a positive 1 and negative 3. I want my middle term to be a single 1. So I'm thinking that if I do a positive 3 and then a negative 2 by putting the negative 1 here, that'll work out for the middle term. So again, negative 2x plus 3x, that'll add up to that middle 1x in the middle. So fully factored. Eventually we'll set each of those pieces equal to 0 in our next section. But right now, just breaking it down as far as we can. The next part is inching us towards grouping. Instead of a common letter and number like 2x, we can take a whole parentheses out that's common, right? So we have 3 separate terms here, but they all have this x minus 3 in common. So what we can do is take that x minus 3 out to the front, and that'll leave x squared plus 2x minus 3. And then this, again, this part that's left over, it is possible that that is a flashcard from multiplies to negative 3, adds to positive 2, x plus 3x minus 1. That is one of our flashcard factorings from the start of semester 1. Again, feel free to pause, rewind, video as needed. So again, I'm going to factor a trinomial. This one does have a leading coefficient, so I can use area model or guess and check. Sometimes guess and check is a little bit easier. We know it's going to be 2 parentheses. We know to get 2x, it's going to be 2x times x. And since it's smaller numbers here, 4 is either 1 times 4 or 2 times 2. So I can think through kind of all the different combinations here. And so I want the middle term to add up to 7. So if I use a 4, that's going to give me like an 8 and a 1. I like that. I think I like that, right? I want a positive 8, so positive 8x, and then a negative 1x for my middle terms to get me to that 7x. So that's guessing and checking. And if I had tried the other combinations there, it would not have gotten to me to the same middle term. You could have also done the area model. That's the kind of 2 by 2 grid. You can look back at semester 1 if you need help with that. What I recommend here is going ahead and hitting pause and try these Try those on your own. Go ahead and hit pause, but I'll reveal the answers here in 1 second. So here are the answers for all 3 of those. Take a look, try them on your own, or ask for help from the sub or another student if you're not quite understanding where those answers came from. But again, we're going to move on to our next part, but these are the try your own. So the idea is you pause before I reveal the answers, try them on your own, and then come back. All right, our new method, factoring by grouping. Here's how we're going to describe this. So this is when you have 4 terms, used for 4-term factoring. okay? And what you do is you look at the pairs. So group into pairs. So the first two and the second two. Factor GCF from each pair. So in this case, my first pair had a GCF of 3x squared that I could divide out. And in my second pair, I had a GCF of 4 that I could divide out of both spots. The last step, then, is if I did this correctly, we're going to factor out our common parentheses. So in this case, that would be the x plus 3 and the x plus 3. I factor that out to the front, and it leaves those GCFs of 3x squared plus 4 that we just had. It leaves that there. This is our final answer, x plus 3 times quantity, 3x plus 4. Again, eventually we are going to set each of those parentheses equal to 0 and solve them, but our new factoring technique is useful only for 4 terms, and that's when you can look at a pair and a pair. It's very similar in the second one, group into pairs. So here I factor this with a 3x cubed. That's the highest number that divides both and the highest power of x that can be divided away from both. And then again, 4x plus 12, that factors away to 4. And again, the parentheses was common, so the x plus 3 comes out, and I'm good to go. What I will do is I will fully work through the try these B, A and B. I'll work those together with you, and then there'll be a few more on the next page where I'll have you pause, try them on your own, and then again, reveal those answers. All right, so let's identify our first two pairs. Here I can take out a common 2 and a common x squared, leaving me with an x plus 5. Again, whatever you have here should multiply back into this if I was reversing this, and instead of unmultiplying, aka factoring, I would multiply it back in, distribute it back in. And here I've got a minus 3 as a common factor, again, leaving with an x plus 5, because the negative 15 divided by negative 3 leaves me with a positive 5, and if I was to reverse it, it would get me back to the beginning. The parentheses match up exactly like I was expecting. So I get x plus 5 times 2x squared minus 3. I'm going to keep that up there. Let's switch colors. Common pair, common pair. I see x cubed. That leaves me with 4x plus 7. And here's a trick. Everything has a common factor of 1. So I can always factor out a 1 if I don't see anything else common. Hey, look at that. Those two parentheses are the same. 4x plus 7 leaves me with x cubed plus 1. And for right now, that's good enough. This second parentheses is something special that we'll talk about on Monday. But for right now, that's all you need to do. Go ahead and pause here. On the next page, if you want to look at numbers 4, 5, and 6, try numbers 4, 5, and 6 on your own. Pause right here, try them on your own, and then compare your answers to mine. And again, get help from a fellow student, substitute as needed with looking at that. So I'll show you the answers here in 3, 2, 1. Hopefully you paused and tried them on your own. Here are the answers for number 4, 5, and 6. So 4 was just a GCF. Factor that out. 5, you could have guessed and checked or used the area model for factoring. And number 6 was the factoring by grouping. So really pay attention mostly to number 6. Get help on number 6 if you still need it. What we're going to do next is we're going to fly forward into lesson 17.2. We're going to keep this same kind of factoring techniques. But what we're going to do is we're going to solve. So we're going to set these equal to 0 and find all of our answers. Okay, so we're going to scroll all the way ahead to 17-2, page 271. And what we're looking at here is this idea of solving with the fundamental theorem of algebra. The big thing for that is essentially if I am a degree 3, I'm going to get 3 answers here. So I get positive I root 2, negative I root 2, and negative 2/3. 3 answers for a degree 3 problem, 2 answers for a degree 2, 4 answers for a degree 4, as long as I'm counting any repeated answers and any imaginary answers. So it should match up. So let's dive into our factoring, set these equal to 0. Anything in yellow we're going to try, and kind of go from there. So again, I'm using only factoring techniques from semester one or grouping. Here I've got a GCF of x. So this is x times x squared plus 9. At this point, I'm done factoring. I'm going to set it equal to 0 to find my zeros. So x equals 0 is my first solution. X squared plus 9 equals 0. I have a little bit more work to do there. X squared equals negative 9. X equals the plus or minus square root of negative 9. So I get x equals plus or minus 3i. So if I write that separately, positive 3i is an answer, and negative 3i is an answer. And I have 3 answers for my degree 3 problem. We're going to see similar way things play out here in each of our problems. So let's jump here to part B. This is going to be a specialty difference of squares problem. So if you remember difference of squares from semester one, a squared minus b squared is a plus b times a minus b. In this case, my squaring is happening twice actually. So I can factor this as x squared plus 4, x squared minus 4, because the x squared times x squared gives me the x to the fourth. 4 times negative 4 gives me the negative 16, and those middle terms add to 0. The cool thing here is that second part factors even further. I can do x plus 2, x minus 2, because it is a difference of squares inside of a difference of squares. And now each separate parentheses can be set equal to 0. X squared plus 4 equals 0. X plus 2 equals 0. X minus 2 equals 0. X equals 2 is an answer. X equals negative 2 is a solution. And a little bit more work here. X squared equals negative 4. X equals plus or minus the square root of negative 4. X equals plus or minus 2i. So if I write them separate, 2i and negative 2i, I have 4 answers for my degree 4 problem. Again, pause at any time, rewind if you need to go back through that. We only have a few more that we'll try together before we give you ones to try on your own, and then obviously your homework will be very similar over the weekend. Letter E here is our grouping one. Notice the 4 terms is what gave it away. 4 terms. That means grouping generally. So we have our pair and our pair. We have a GCF of x squared in the first half, leaving me an x plus 5, and a GCF of 9 in the second half, leaving me with an x plus 5, set it all equal to 0. We know it works because those parentheses are exactly the same, leaving me with x plus 5 times x squared plus 9 equals 0. Set each parentheses equal to 0. So x plus 5 equals 0, x equals negative 5, my first solution. X squared plus 9 equals 0, x squared equals negative 9, x equals the plus or minus square root of negative 9, so plus or minus 3i. So if I write it separately, I do get 3 answers for a third degree polynomial. Eventually we'll learn how these impact the graphs, but that's a good sense of if it's setting equal to 0, how you finish and solve. On this next page, I recommend trying 1, 3, and 4 on your own. Go ahead and pause here. Try them on your own. Come back to check your answers. I'll reveal those in 3, 2, and 1. Hopefully you tried those on your own. So again, feel free to pause and analyze the work. The first one, difference of squares twice, leading to 4 answers. Number 3 is a GCF, where I get an x equals 0, actually twice. And then again, 2 imaginary answers. And number 4 is our grouping again. I forgot to circle it down here, but I do have 3 answers for my third degree problem for the grouping. Hopefully that gives you some good practice to try with it. There'll be other videos from Khan Academy in the folder as well if you want to reference those for practice. Give it a try. I know it's always tough your first time doing this kind of from the video and then trying it on your own over the weekend, but I've got great confidence in you. Give the homework a try. Come with lots of questions on Monday, and we'll clean up. We're going to be in these same 2 sections, just doing a different strategy on Monday. So I look forward to seeing you on that day. And otherwise, take care and have a good rest of your day.